Question 6. The shape OABCDEFO, shown in figure 1, is a design for a logo. In the design, OAB is a sector of center 0 and radius r. Sector OFE is congruent to sector OAB, so these two will have the same area. ODC is a sector of the circle center 0 and radius 2r, and AOF is a straight line. Given the size of angle COD, which is this one here, which is labelled theta radians, part A, write down in terms of theta the size of angle AOB. Right, so if we label on AOB, let's call it X, AOB will be equal to EOF, which is also been labelled X here because these two sectors are congruent with one another. Now, I know that this AOF is a straight line, and because it's a straight line, it means these angles add up to 180 degrees on a line. We are in radians. 180 degrees is the same as pi radians. And so, since a straight line is pi radians, I know that my 2x here plus theta must equal pi. And I can rearrange this to say that my angle x, so subtracting theta and then dividing by 2, my angle x is equal to pi minus theta divided by 2. So that's my part A. Part B, I want to show that the area of the logo is half r squared 3 theta plus pi. Now, the first thing I want to note here, because I've got quite a few sectors, is the area of a sector. So when we're in radians, the area of a sector is given by half r squared theta. Now, I've got two sectors to consider. I've got the OAB, OEF, and then I've got the OCD. So if I look first of all at this sector here, OEF, so I like to give a little diagram to help me work through the question. So I'm looking at my area of this OEF, and I know this area to be half r squared, and the angle is x, which I've found to be pi minus theta over 2. Now I know I'll have two of these, but the second sector I need to find the area of is my OCD. Again, I've got a rather poor diagram. And the area of this sector is going to be the half 2r, it's the radius of this, all squared, times theta, which is the angle in the middle there. And now the area of my complete logo is 2 lots of this OEF. So 2 lots of the half r squared pi minus theta over 2. That's for the OEF and the AOB. Plus the area of my OCD sector, which is half 2r squared theta. So I can expand and simplify this on the right hand side. So 2 lots of half just leaves me with r squared lots of pi minus theta over 2. Being careful here, it's the 2r all squared. So it's half of 4r squared theta. A half r squared can be taken out of this as a factor to leave me with pi minus theta plus 4 theta, which of course simplifies to 3 theta plus pi. And so a half r squared 3 theta plus pi is my logo area, which is what I wanted to show. Part C, I want to find the perimeter of the logo, giving my answer in simplest form in terms of r theta and pi. Well, if we start with our formula for arc length when we're working in radians is r theta. And so I've got 2 arc lengths that I'm interested in. I've got my E to F and my C to D. Now my arc length E to F is r theta. Remember, my angle here of x we found previously to be pi minus theta over 2. E to the F is the same as A to B, so I don't need to find my A to B. But I do need my C to D arc length, and C to D is r theta. R is 2r in this case, and theta is theta. Now that I have the arc lengths, I can find my perimeter, which is my lengths around my shape. So I'm going to do this clockwise. So starting from 0, my perimeter is r EF, which is r pi minus theta over 2. This length here is r, since this radius is 2r, but this has a radius of r. This leaves me ED is r. Now plus CD, which is 2r theta, plus r, plus r lots of pi minus theta over 2, plus r again to get me back to 0. So I've added all of my sides together. This simplifies, give me 4r plus 2r pi minus theta over 2 plus 2r theta. Simplifying the middle term here just by cancelling out the 2. Leaves me with 4r plus r lots of pi minus theta plus 2r theta. Expanding the brackets, 4r plus r pi minus r theta plus 2r theta, which simplifies to 4r plus r pi plus r theta. Now I can take out my factor of r, and I have r lots of 4 plus pi plus theta, which is the perimeter of my logo.